So in this problem, we're given an inequality for x, and then we're asked which of the following statements must be true. So the first step is to rewrite this. We can multiply both sides by 3, get 12. It doesn't change the sense of the inequality because 3 is positive. Add x to both sides. 12 plus x is less than 7. Then subtract 12 from both sides, and I get 7 minus 12. So x is less than minus 5. So we know the original inequality is equivalent to x is a number less than minus 5. So let's look at number 1. It says 5 is less than x, or x is greater than 5. Well, certainly that's not true. So 1 is out. Number 2 is absolute value of x plus 3 is greater than 2. So there are two ways. We can either just look at these values and see if that would satisfy this under all circumstances. And one way to do it is when x is equal to minus 5, this is going to be minus 5 plus 3, absolute value of minus 2, which is 2. But if it's a number less than minus 5, for example, let's say minus 5.2, this would be minus 5.2 plus 3, which is absolute value of minus 2.2, which is 2.2, which is indeed greater than 2. And if we select any value that's less than minus 5, any numbers here, their magnitude, meaning in terms of numerical value, would be greater than 5. And so when we add 3 to it, and it's a negative number, we'd get a number just in magnitude greater than 2. And this would always be true. So 2 must always be true. That's one way to do it. The other way is to, if I had to solve this inequality, and it comes up in other GMAT problems too. And the way to think about this geometrically is that this is x plus 3 same as x minus minus 3. And the interpretation of this on the number line is that if we have a number, let's say minus 3 here, then x minus minus 3 is the distance of x from the point minus 3. And what this inequality says is that we're looking for the set of all points that are 2 units or more away from minus 3. So the two sides of minus 3, the two numbers that are 2 units away are minus 1 and minus 5. And we're looking for numbers that are greater than 2 units from minus 3. So these are all the possible values of x on both sides. And we'll see that this inequality is equivalent to either x is greater than minus 1 or x is less than minus 1. And because our main equation gave us that x is less than minus 5, I'm going to satisfy this absolute value inequality for all values of x. So that's another way to do number 2. Now number 3 says minus of x plus 5 is positive. And we found that x is less than minus 5. So one way we can do this is to just rearrange this. And we can rewrite this as minus 5 is greater than x. Subtract x from both sides, and we get minus x minus 5 is greater than 0. And we'll notice that the number 3 is really exactly equivalent to these two. So 3 also holds true for all values. Another way, I mean, if you're not comfortable doing this manipulation, you could also think in terms of numbers. You could say, okay, x is a number less than minus 5. So I know that this number, for example, if x is minus 5.2, is going to be negative. So in this case, negative 0.2. But having a negative outside makes it positive and would be indeed greater than 0. And that would be the case for all values of x that are less than minus 5. So to recap, 2 and 3 must always be true, and the correct answer is choice D.